I'm getting a bit bored of my current Minecraft skin. How about we choose a new one? What about an Orc Warrior? That sounds cool. Well, I'm not making my own Minecraft skin. Hmm. What if I just made an AI to do it for me? Surely that's more time efficient. By the way, I'll tell you guys how to use the AI at the end of the video. First, we need to discuss how to actually make this AI. The first thing we'll need to do is to get the actual dataset to train the AI on. This dataset will also have to be high quality in terms of both the skins themselves and their description, since we're going to add the ability to make skins with prompts. We did this by scraping skins from a highly moderated website that fits all of those requirements called MinecraftSkins.net with a custom web scraper written in Python, which you can check out in the previous video linked in the description and above. As for the AI itself, while we could use a custom UNet conditional model, which is basically a fancy way of saying a specific type of neural network architecture commonly used with image generation AIs, we'd have a major problem, which is not being able to make anything outside of the dataset, which isn't very large, especially considering the fact that we're gathering this data from just one website, and not even a very large one at that. This forces us to narrow down our options if we want this skin generator to be able to genuinely generate new skins. So, what we need is a large open source model that's been trained on countless other images, leading me to eventually choose Stable Diffusion, which is an open source and freely available image generation model. Training the whole Stable Diffusion model itself would be too expensive, so we'll use something called LoRA, aka Low Rank Adaptation, which is perfect for our case where we need Stable Diffusion to deviate massively from its original training data, while only wanting decently small files to store the model and having not very powerful GPUs to train the AI to say the least. It basically allows us to train a Stable Diffusion model to do something specific by modifying a small amount of specified weights within the neural network rather than the whole thing, which is what will allow for us to train the AI with our limited resources. Not only is Stable Diffusion already very powerful, but by training it, we'll be able to teach it how to rate the Minecraft skins with what it's already been trained with, which will allow us to create a model that can create entirely new skins based on what it's already been trained on and the new training data that we're giving it. In order to actually train the AI, we take all of these concepts and apply them by taking the scraped data and converting it to a form for training the AI via a Python script, and then tweaking a LoRa trainer for Stable Diffusion to train a model for us. Since I don't have a GPU suitable for training an I used Google Colab with some compute units since Google Colab doesn't allow this type of training unless you've paid. Then we add our model to a script so that you can use it in Google Colab. Also, some of you might have heard of a team called Opposite AI who started working on a Minecraft skin generator around a year before mine. If any of you guys are watching, I just gotta say, you're my arch nemesis now, even though you probably don't know who I am. I'm just joking, but it'll be interesting to see how both skin generators progress as time goes on. Now here's how to use the AI yourself. First, what you'll want to do is scroll down and press Open in Colab next to Skin Generator. Then what you'll want to do is to click on Change Runtime Type and choose the T4 GPU. While there are other options, they're either ineffective or locked behind a paywall. Now you can run the program by pressing Runtime and then Run All. You can safely ignore the warning. What Google Colab will now do is run all of the code blocks from top to bottom one by one, but before you get to the actual generation part, there are still a few steps required. When the first program is done, what it'll present you with is a login screen. If you don't already have what's required, like I do here, you'll want to click on the link and create a Hugging Face account before clicking on the link again and creating a read token by pressing the New Token button, which you will then paste into the token input before you enter Y for the second prompt and let the rest of the code blocks run. What the second code block will do is download the Stable Diffusion model, attach the LoRa, and specify the device used for running the neural network, which in this case is the T4 GPU. By the way, although there are other parameters other than the prompt itself, I wouldn't recommend messing with them unless you know what you're doing. The last code block is the block that generates a skin and contains the parameters for doing so, which are skin name, skin category, and skin description for generating the skin, and can be ran multiple times after running the first two code blocks to generate more skins. It generates skins as outputs underneath itself, which can be right-clicked on to be saved and used. By the way, in case you're wondering what the final downloaded skin looks like, here it is. Something to note is that AI oftentimes won't follow the instructions given, especially for things that it hasn't been trained on, which means that you'll want to try generating your skin with prompts best suited for the AI. This problem will likely be drastically decreased with more training since the AIs only went through 18 epochs, with epochs being iterations over the whole dataset when training an AI, while a lot of models can use hundreds. I'll most likely be asking a friend with a gaming GPU to help me train it, but if you're willing to help train it and send a pull request with the new models, that would be appreciated too. To do so, you can follow the instructions on the GitHub. I also recommend that anyone trying to mess around with the skin generator, even if they're not trying to train it or anything else, joins our community on Discord, which will be linked below. By the way, if you're interested in this sort of tech-related content and want to see more, please hit the like button and subscribe since I hope to publish a lot more of this content onto the internet and your support means a lot.